Okay, sir. I'm host now. Okay, sir.
Sir, presentation. Your
Ah,
display presentation.
share. One note. Visible as sir?
Yes, sir. Yes, sir. Yes, sir.
Okay, sir.
Here one note is there.
Okay, okay, sir. I will start in 5 minutes. Na?
Okay, sir. No problem. Sir, just remember to start recording.
Recording is just started.
Okay, no issue, sir. Thank you, sir.
Oh, okay, thank you. Now we are starting with new topic, which is case code amplifier. Case code amplifier. So our title for the day is case code amplifier. How to design, or better to say, how to analyze one case code amplifier. So let's start. What is issue related to case code amplifier and how we can design it? That we will discuss today. So what I can say, the basic gain cell, when you design at level of IC, you can say basic gain cell is either common emitter or common source. So in case of BJT, you can have the common emitter is basic gain cell. And in case of MOSFET, in case of BJT, the first one is true. And for the MOSFET, the second is true. For the BJT, first is true, and for the MOSFET, second is true for the MOSFET. So what is common? Let's draw a MOSFET. Let's draw the cascode amplifier using first. I am using this as a using BJT. I am with the help of BJT. So what we can say that this is our emitter, and this is VCC, this is RC, and this is, let's say, this is your input, a small signal input VI. And from this point where we are taking output, this is V out. So this is the whole idea. What you can say, this is basic gain cell. The basic gain cell and what I can say, the gain of this amplifier is equivalent to minus GM into RC. So we are working on basic gain cell. How we can have a better result? How we can have a better result? We are searching for the replacement of. We are searching for the replacement of RC. We are looking for the replacement of RC. Replacement, or I would say we are looking for the alternative for RC. What is the alternative for RC? So what is problem with RC? Problem RC के साथ क्या है? Let's see the first problem. When you go to the IC level, at IC level, it is very difficult to mount a resistance in the IC. Right? So what is problem with IC? I can say the problem with IC is this. First point, it's difficult in IC technology to implement रजिस्टर्स, है ना। आईसी डिजाइनिंग की बात चल रही है, तो आईसी डिजाइन में क्या इंप्लीमेंट करना है ना, सारा कुछ अगर बीजेटी से ही बन जाए तो यू कैन टेक एडवांटेज ऑफ सिमिलरिटी. सो फर्स्ट थिंग, द सेकेंड थिंग इज you cannot select, as we know the gain is a function of RC, the voltage gain is a function of RC, but same RC is responsible for fixing the Q point. The same RC is responsible for biasing point. So what is alternate of IC? So I can say the alternate of IC, what IC is doing, RC is supposed to provide a constant collector current. What is the working of RC? RC required to perform two tasks. This should perform constant current. Which current? Collector current, है ना, which is responsible for biasing, and provide high resistance. High resistance. This is our expectation from it should provide high resistance because our gain is dependent on the resistance. High resistance is we want a constant DC currents. So to stabilize the biasing point, this is requirement of biasing, and the second is requirement for the gain, small signal gain. So can I replace this with a current source? What I am trying to say that can we do this? I am looking for this. This is resistance RC. And what I am saying, instead of using RC, can I use this? A current source IC. And yes, this will provide a resistance RO. Because the main working of IC, the main working of IC is main working of RC is to provide a constant current and provide high resistance. So you can say if we are able to design, if we able to design a good current source, a good current source, good current source can solve our purpose. एक बहुत अच्छा करंट सोर्स हमारा पर्पस सॉल्व कर सकता है. So this is the idea. So can I improve this? I can improve my basic gain cell. I can improve my basic gain cell by this. I can say improved gain cell will be looks like this. Improved gain cell will be looks like this. We are having one and here I can use one current source. This current source is having value equivalent to this is your VCC and this is your base, and we are supplying input here and we are taking V output from here. This is V out. So can I say the gain of this amplifier? The gain of this amplifier is minus GM into RO. And what you can say, this RO is output resistance of internal resistance of current source. This is what? Internal resistance of current source. RO is internal resistance of the current source. Now what I can say, now I can have the BJT equivalent of this current source, and that is current buffer. A current buffer cell means a circuit having gain 1. So you can say we will use a current buffer. Or what I can say, a circuit having current gain is approximately equivalent to 1 will solve our purpose. And replacement of this current source will be, the replacement of this current source will be what? The replacement of this current source will be a common base arrangement. So what is case code amplifier? Case code amplifier is a circuit having input at, we will apply input at common emitter terminal, common emitter configuration. This will act like input, and we will take output through common base. This arrangement is known as case code arrangement. This arrangement is known as case code arrangement. So what I can say, let's start. This is our common emitter circuit. Then we are having this. Then we are having common emitter. So this is common emitter. This is common emitter. Then we are having one collector terminal. Then we are having one common base arrangement. So you can say this is common base arrangement. Base is connected to ground or a DC. I am drawing the AC equivalent. And this is our collector terminal. This type of arrangement is known as This type of arrangement is known as cascade arrangement. इस type का जो arrangement होगा, that arrangement is known as cascade arrangement. And let's analyze what is the meaning of cascade arrangement, है ना? इसको analyze करते हैं. So what we want, our expectation from the circuit is to have this. And we can take output from here. So this arrangement is common emitter and the second arrangement is common base. So this is our idea for the circuit. This configuration is known as cascade configuration. So let's start the analysis, small signal analysis of cascade configuration. So let's start with the small signal model of cascade configuration. So what we can say, this is our cascade circuit. This is at signal ground. Then we are having one common base. Then we are having one common emitter. Now purpose of everything is very clear. What we want a good quality of high resistance, and this is Vi, and we are taking output from here. This is V output. This is our whole arrangement. This is cascade amplifier. This is cascade amplifier. So let's draw, it's a small signal model for the cascade amplifier. Let's draw the small signal model for cascade amplifier. How cascade amplifier will work. So what I can say, let's draw the hybrid pi model to analyze this. Let's draw. And what is our intention? Our intention is this. Our intention is this. Let's say this is GM into Vi. Then we are looking for the new output resistance. New output resistance from this arrangement. तो एक तो हमें ओवरऑल ट्रांस कंडक्टेंस व्हाट GM is equivalent to overall trans conductance, and I am interested in RO also. RO is output resistance. So we are looking for a technique which can enhance your output resistance. Okay. So let's draw this. Let's draw the small signal model for this. तो पहले मैं कॉमन इमीटर की आंटी है. So what I can say, I have first common emitter amplifier. So let's draw this. It may be a big circuit. So I am drawing here small signal model. A small signal model. How we can draw? So first let's take, we are having this VI. So first we are having R pi 1. This is R pi 1. This is VI equal to V pi 1. Now, this is our what I can say. This is GM1, the transconductance of first amplifier into V pi 1, or directly I can write this as a VI. क्योंकि यहाँ बेस इमीटर जंक्शन में जितना पोटेंशियल ड्रॉप होता है उतना आपको करंट मिलेगा. Now what I can say, let's say we are having one output resistance RO, है ना. यहाँ एक जो करंट सोर्स है उसका आउटपुट रेजिस्टेंस ले लिया मैंने RO1, है ना. And this is arrangement for the first transistor. ये पहले ट्रांजिस्टर के लिए लिया है हमने. So what you can say, this is B1, the base of transistor 1. And which transistor I am saying B1? This is B1. This is E1 and collector is C1. So this is C1. And emitter is connected to ground. So we have taken that emitter to the ground. Now we want to connect one more small signal model to this circuit. And what we can say, the collector of first terminal, the C1 is connected to E2. So let's start with this point. So can I say this is our base terminal B2, and we know that B2 is connected to ground. This is R pi 2. This is V pi 2. Fine. Now we are having one more. The source for this, which is GM2 into V pi 2. And what else we can draw? The else we can draw is a resistance, output resistance R02. And this is our C2. And C2 is also connected to ground. So C2 is also connected to ground. So this is whole idea. And this is our C2. This is our collector of 2. Means C2, B2 and E2, we are taking this term for common base, and C1, B1, E1, collector 1, base 1, emitter 1, we are taking this for common emitter. So this is the idea. This is our circuit. This is a small signal model for the cascode amplifier. What I can say, this is a small signal model for cascode amplifier. A small signal model for cascode amplifier. A small signal model for cascode amplifier. So let's calculate. Let's calculate the every term related to this. So can I say this potential is V pi 2. So this potential is what? This current I can draw here is V pi 2 divided by R pi 2. है ना, यहां से करंट इंटर करेगा तो हायर दिस इज V pi 2 minus R pi 2. Current from here we can say V pi 2 divided by R02. है ना, ध्यान रखें ये जीरो पे नहीं है. Current here will be VI divided by R01. So I can apply node at this terminal. है ना, let's say this terminal is 1 prime and I am applying KCL at 1 prime. The KCL at 1 prime. The KCL at 1 prime is given by total incoming current is equivalent to total outgoing current. So you can say V pi 2 divided by R pi 2 plus GM2 into V pi 2 plus, this all current is coming to the node. V pi 2 divided by R02 is equivalent to, this 3 current is incoming to the node and 2 current is outgoing to the node. So we can say this is GM1 into VI1 VI plus VI divided by R01. This is the KCL at so now what I can say, these currents are insignificant. V pi 2 divided by R pi 2 is base current. In comparison to collector current, it's 100 times less. This is also very less current. This is also very less current. So what we can say, GM2 into V pi 2 is equivalent to GM1 into VI. This is a very important relationship which will help you. Suppose I am interested in total transconductance of the circuit, है ना? मुझे एक बात जो पता करना थी वो क्या थी? I am interested in the total transconductance of circuit so that I can calculate what are the important parameters which I need to calculate. The first parameter is this and second parameter is output resistance, so I can get the gain कि भैया इस एम्पलीफायर को यूज करने से कुछ फायदा हुआ या नहीं हुआ. So let's start. How to calculate? So we are interested in output current. So what is output current? We can easily find the value of output current from this. You can say the total output current of the circuit is given by this. This is output current. So I can say output current is divided into two parts, this part and this part. So you can say the output current IO, the output current IO is summation of two things. The one is the summation of two things. The one is GM2 into V pi 2 and second is V pi 2 divided by R02. So this what I can say, this is GM2 into V pi 2 plus V pi 2 divided by R02, and you can neglect this. So you can say, because this output resistance is expected to be high, very high, and now I can say the IO is output current and GM2 V pi 2 is what? GM1 into VI. You know that IO is output current and VI is input voltage. So it's the output current of complete cascade and this is input voltage. So this is known as GM, which is overall transconductance. This is overall transconductance, and what I can say, the overall transconductance is known as GM. And what is value of GM? The value of GM is equivalent to GM1. कि केवल किसके ट्रांसकंडक्टेंस पे डिपेंड करेगा? केवल कॉमन इमीटर के ट्रांसकंडक्टेंस पे डिपेंड करेगा इसका ओवरऑल ट्रांसकंडक्टेंस. So overall transconductance is dependent on GM. So this is our first observation. Now we are interested in output resistance of this amplifier. Now we are interested in output resistance of this amplifier. The output resistance of cascode circuit. We are improving the quality of amplifier. So what is output resistance of the cascode circuit? So how to calculate output resistance, and what is definition of output resistance? As we know, the output resistance is given by R out of the circuit is given by the ratio of V test divided by I test by making Vi equal to 0, है ना. इनपुट को 0 करके जो भी हमारे पास सर्किट बनेगा that will be considered as a R out. So let's start the analysis of output resistance. It's very important to analyze the output resistance because we want a higher output resistance for the better gain condition. So what I can say, how to calculate the output resistance? Let's say we are having this, the calculation of output resistance. The calculation of output resistance. So what I can say, how to calculate the output resistance? Vi equal to 0. So let's say what I am saying, let's make Vi equal to 0. So this is our circuit. This is our circuit. क्या था यहाँ? I can say this is our circuit. Let's start from here. This is okay. This is our base terminal. Then we are having R pi 1. This is our Vi. Then we are having one base. So let's take, this is our base. This is GM1 into Vi. This is R01 then we are having one VR pi 2. This is connected to ground. Then we are having one GM2 into V pi 2. This potential is V pi 2. Then we are having one R02. Then we are having one टेस्ट सोर्स है ना. अब यहां मैं टेस्ट सोर्स लगा देता हूं. लेट से टेस्ट सोर्स इज अवर वी टेस्ट है ना. आउटपुट कैसे निकालते थे हम, यही तरीका है. दिस इज वी टेस्ट और ये वी टेस्ट करंट ड्रॉ करता है आई टेस्ट. So we are interested in what is output resistance. You can say output resistance is nothing but the ratio of V test divided by I test by making Vi equal to 0. This is our definition of output resistance. So what I can say, if Vi is equivalent to 0, आप जरा ध्यान से देखें क्या क्या चेंजेस होंगे. If Vi is equivalent to 0, this current source will be 0. And you can say the starting point and termination point of this two R pi 2 and R01 are same. ये दोनों स्टार्ट होते हैं इसी पॉइंट से माइनस वी पाई 2 से और टर्मिनेट होते हैं 0 पे. ये देखो दिस इमीटर इज आल्सो कनेक्टेड टू 0. सो कैन आई से R pi 2 will appear in parallel with R01. This is the idea. So what I can say कि what is value of this current है ना. जरा निकालते हैं हम कि let's apply the KVL in this circuit. Let's apply the KVL in the given circuit. KVL in circuit. So what you can say, here the current is let's say I test minus GM2 into V pi 2. अरे टोटल इनकमिंग करंट है आईटी, आईटी में से GM2 into V pi 2 गया तो यहाँ कितना जाएगा, आईटी माइनस GM2 into V pi 2. सो कैन आई से दिस पोटेंशियल प्लस दिस पोटेंशियल प्लस दिस पोटेंशियल इज इक्विवेलेंट टू. और इस पूरे सर्किट में अगर इनकमिंग करंट आईटी है तो यहाँ से बाहर निकलने वाला करंट भी कितना होगा, आईटी. दिस इज द बेसिक रूल ऑफ नेटवर्क एनालिसिस. इनपुट करंट इज ऑलवेज इक्विवेलेंट टू आउटपुट करंट. So with this theory, what I can say that the result for the KVL is equivalent to minus of VT minus VT plus we have one more potential which is IT minus GM2 into V pi 2 multiplied by R02 plus one more potential R01 in parallel with R pi 2 multiplied by IT. So this is the whole idea for the सर्किट की सर्किट का पूरा आइडिया कितना होगा, ऐसा होगा. Okay, we have one more relationship which is which we know. So we are, and this is equivalent to 0. इस पूरे का समेशन कितना होगा, the value of this circuit is equivalent to 0. इसका value 0 होगा. Now we are having IT in every term because we are interested in ratio of VT by IT, but V pi 2 is not connected to R pi 2. So can I say from very basic relationship, this potential is minus V pi 2. So can I say minus V pi 2 is nothing but IT times of R01 in parallel with R pi 1, or not R pi 1, it's R pi 2. R pi 2. Why we are saying this? Because you can say a current IT is flowing in this terminal. The one is this and another one is this. And what I am saying, this is R01, this is R pi 2. And what I am saying, that this potential, whatever the potential appears here is, whatever potential appears here is minus V pi 2. So this is the relationship which we know. So I can replace it. है ना, अब तो मैथमेटिक्स वाला काम हो गया है, तो बड़े आसानी से हम कर सकते हैं. दैट VT plus IT. Okay, IT is acceptable because we want IT in our discussion, because we are interested in ratio of VT by IT. Minus GM2. Minus GM2 is no problem in minus GM2 into V pi 2. V pi 2 is known as IT times of R01 in parallel with R pi 2. Whole multiplied by what? This whole is multiplied by R02 plus, can I say this resistance is R01 parallel with R pi 2, and we know that R pi 2 is much lesser than R01. So in parallel combination, which number will dominate? The smaller one will dominate. This multiplied by IT. So can I say the value of VT by IT the value of VT by IT VT by IT by making Vi equal to 0 is, है ना, and this is minus minus कितना हो जाएगा plus. So this is R02. Which resistance is R02? I am multiplying this to 1 is R02 plus GM2 into R02 into R01 parallel with R pi 2 plus it's a R01 in parallel with R pi 2. This is output resistance of this amplifier. So what I can say, let's have some meaningful answer from this. This is R02 plus GM2 into R02 into R01 is higher resistance and R pi 2 is less resistance. So you can say this is approximately R pi 2. And you can neglect this. You can, the resistance is higher, we are taking it lesser. So R01 into R pi 2 is again, this is R pi 2. R pi 2. Okay. GM2 into R pi 2 is what? Beta. Beta 2. Beta 2 is 100 times. So you can neglect this 2 number also. So can I say, है ना, we are overestimating, मतलब हम कम वैल्यू लिख रहे हैं जबकि एक्चुअली ज्यादा वैल्यू है. तो बीटा 2 into R pi 2, GM2 into R pi 2 is equivalent to beta 2 into R02. So can I say this circuit is nothing but a resistance magnifier? This circuit is known as a resistance magnifier, है ना? Resistance amplifier. You can say it amplifies the resistance. कि पहले कितना resistance था? It's R02. Now you are having resistance what? Beta 2 into, it's 100 times more than your. So can I say resistance magnifier? So can we have the output resistance, out voltage gain now? So yes, we can have the voltage gain of the cascode circuit. So in cascode circuit, what I can say, this value is GM. This is GM1 into VI. The next circuit is what? RO. And this is your V out. So what we can say, V out for the circuit is equivalent to minus GM1 into VI into RO, which is beta 2 into R02. So you can say the voltage gain is equivalent to minus GM1 into beta 2 into R02. So you can say, let's say, what I can say, if GM1 and GM beta 2, yeah, I should say R02 is, let's say, approximately R01, then what I can say, the gain is equivalent to minus GM1 into R01. ये क्या था? This is your basic gain. जो गेन का इक्वेशन आया था वो कितना आया था? जब मैंने डिस्कशन स्टार्ट किया था तब आपको क्या बताया था कि by using a current source you can have gain is equivalent to this minus GM into, you can say this is the basic expression for the gain. ये gain का basic expression होगा. And if this is the basic expression for gain, what I can say, GM1 into R01 is basic gain. है ना? Let's write this is a A0. So this is A0 into beta. So what I can say, basic gain is also enhanced by beta. And this is the beauty of MOSFET circuit. So what MOSFET circuit is doing? MOSFET circuit is doing what? MOSFET circuit is acting as a resistance amplifier, resistance magnifier. So this is MOSFET circuit based on BJT. This is BJT based MOSFET circuit. BJT based MOSFET circuit. BJT based MOS. This is BJT based MOSFET circuit. Now let's analyze one same we can have with the same logic we can analyze a MOSFET based MOS circuit. What I can say, we can have its alternating is MOS based MOSFET based. We can have MOSFET based cascode circuit. So what is MOSFET based cascode circuit? The approach is very similar to this. We are having one arrangement which is known as, we are having one circuit which is this is common source and one arrangement is known as common base arrangement, and we are taking output from here. So this is cascode circuit, this is common gate arrangement. So this circuit will also act as a this is cascode MOSFET circuit. This is cascode circuit based MOSFET based cascode circuit. So you can analyze in the same way, है ना? इसका भी small signal model बनाए. Small signal model will solve the purpose. Let's take few example based on this. कुछ एग्जांपल सॉल्व करते हैं इसी सर्किट पे बेस्ड. Let's take few examples. A circuit is given by this. This is 5 volt. Then we are having this is from gate 2017. This is 1 kilo ohm resistance. Okay. This is VI. Then we are having one more transistor. This is connected to minus 5 volt. Then this is RB2. This is capacitor and this is ground. And we are interested in V out for this. What will be the output voltage for this? We are interested in V out for this transistor. अब यहाँ आप एक बात ध्यान रखें, whenever हम पहले भी डिस्कस कर चुके हैं, whenever this collector, whenever there is a short circuit between, there is a connection between this कि बेस और कलेक्टर दोनों अगर जीरो हो तो यू कैन रिप्लेस योर होल अरेंजमेंट बाय, है ना, वी आर टॉकिंग अबाउट दिस अरेंजमेंट फॉर a transistor. What I am saying, whenever these two are connected, we can replace our whole circuit by 1 by GM. ऐसा हम कर सकते हैं. कैसे, जरा देखें इसको. At first we are having this. This is minus plus V pi into this is R pi. This is emitter. Then what we are having, this GM into V pi and this is our collector terminal. And when these two terminals are connected, short circuited, you can say what will be the resistance of this? This whole current will flow through here. It's a GM into V pi into R pi is equivalent to V pi. So V pi and V pi cancel. What is value of R pi? 1 by GM is equivalent to R pi. So this is the idea. When you are having short circuited base and collector, you can replace your whole circuit by 1 by GM. Now the things are very simple. अब बहुत ही अगर दूसरे ट्रांजिस्टर का मेरे पास स्मॉल सिग्नल इक्विवेलेंट अवेलेबल है, तो व्हाट आई कैन रिप्लेस? आई कैन से my new small signal model will be what? Small signal model will be this. First we are having a Vi, then we are having one kilo ohm, then we are having one resistance of 1 by GM. And when you are having one, what else is given for this circuit? The else is given for this circuit is the collector current for the circuit is 2.5 milliampere. IC for the circuit is given as 2.5 milliampere. So we know the value of GM is equivalent to what? This is IC by VT. So you can say the GM is equivalent to IC is 2.5 milliampere divided by VT is 26 millivolt. So this value comes out to be 2.5 divided by 26. So you can say 100 millimho, and 0.096 means you can say this is 100 millimho. And the exact value is what? The exact value comes out to be 0.0961. So 100 millimho is a good approximation. Let's start how we can analyze this transistor. Let's draw the small signal model. So what I can say, I am interested in a small signal model. And what I can say for a small signal model, I will draw for hybrid, not hybrid pi, I will draw for RE model. I will go for RE model. So this is our base terminal. This is our base terminal. This voltage is Vi. Then we are having one more current source. This current source is having value GM into VBE. Then this is connected to collector. And what is value of collector? Resistance is 1 kilo ohm. Then what we can have? We are having one R pi and one resistance GM. So this value is RE. What I can say? This value is RE. This is VBE. And this is 1 by GM. Or what I can say, this value is also equivalent to alpha into IE. So I can say V out for the signal is equivalent to minus GM into VBE into 1K, or V out is equivalent to minus alpha into IE into 1K. Now what I can say, the beta of the transistor is okay. Beta of transistor is given as very large, so you can take beta is approaching to infinite. So you can say beta divided by 1 plus beta is equivalent to alpha. So when beta is approaching to infinite, beta and 1 by beta is same thing. So answer will be 1. So you can say V out is equivalent to IE. And what is IE? It is VI divided by RE plus 1 by GM multiplied by 1000 or 1K. So you can say V out is equivalent to GM into RE plus 1 into 1000. Now GM into RE is equivalent to what? GM into RE is equivalent to alpha. So 1 plus 1 is 2, and GM is equivalent to 100 into, this is 100 divided by 2. So you can say gain is equivalent to 50. है ना? 100 कितना आया था? मिलीमो. और ये कितना आया है? 1K. तो milli and K is cancelled. So what is answer for this question? Answer for this question is 50. So how you can analyze this question? Let's start with the another problem. है ना? ये बहुत ही अच्छा क्वेश्चन था जिसमें आपको सारे रिलेशनशिप यूज करने थे. ऑफ कोर्स ये इसी में ही पूछा जाएगा. GM into RE is equivalent to alpha. GM into R pi is equivalent to beta. R pi divided by 1 plus beta is equivalent to RE. है ना? ये बहुत बेसिक रिलेशनशिप है जो हमें पता होना चाहिए. Okay. Let's take one more problem based on the same concept. The concept of cascade amplifier is this. We are having beta is high for this circuit. This is given. In AC equivalent circuit of a BJTs are biased in active region, have identical parameters. Beta is very high. Open circuit is small voltage gain. आपसे पूछा है कि open circuit small voltage gain कितना होगा, and circuit is given like this. This is my circuit. This is connected to ground. Then okay, then we can say now we are having this arrangement. This is V out. This is VI. So they want a mid-band voltage gain for this amplifier circuit. इस amplifier circuit का mid-band voltage gain निकालना है. Again, what I can say, the base of this transistor and collector of this transistor is connected. And when base and collector of transistor is connected means you can replace it by what? You can replace it by 1 by GM. You can replace your whole transistor by 1 by GM. Now the things are very simple for this. इस सर्किट के लिए अब तो चीजें बहुत आसान हो जाएगी. You are having only one. You are having only one circuit, and which is common source amplifier. So you can say the circuit is now like this. The equivalent circuit to this is, है ना, कैसा सर्किट बनेगा? You can say this is my VI. This is my VI. Then we are having this is 1 by GM. So you can say in a small signal model, this is 1 by GM. This is connected to the AC ground, and we are having one emitter terminal which is connected to ground. So this is common emitter amplifier with emitter resistance is equivalent to collector resistance is equivalent to 1 by GM, and there is no loading effect also. So what I can say, what is a small signal model for this? वैसे तो उसको भी बनाने की जरूरत नहीं है. Small signal model, the small signal model for the circuit is given by what? This is R pi. This is VI. Collector is connected to ground. This is V pi. Then this is GM into VI because there is no loading. And here we are having collector resistance, which is 1 by GM. Because all parameters are identical, otherwise we will take GM1 and GM2. So you can say what is output of this circuit? The output of this circuit is equivalent to V out is equivalent to minus GM into VI into 1 by GM. So you can say V out by V in ratio is equivalent to -1. So what I can say, the voltage gain of this amplifier is equivalent to -1. Output is 180 degree out of phase with input. So this is the answer for the given circuit. Now let's take a few more problems. Let's take one problem based on this. We are having one 12-volt source. Then we are having one R1. R1 है ना, चलो देखते हैं. This is R1 and this is the R2. What else is given? Two transistors are given. This is VI. The first transistor is VI. This is connected to ground. Then this is minus 12 volt. This resistance is R3. This is VB. Okay, this circuit is given. What else is given for this circuit? That R1 is equivalent to R2 is equivalent to R3 is equivalent to 1 kilowatt resistance. What else is given? VBE for the circuit is equivalent to 0.7 volt. What else is given? Beta for the circuit is equivalent to 100. Okay? And the collector current of transistor Q3 is 2 milliampere. The IC3, this is Q1, this transistor is Q2, and this transistor is Q3. What they are saying? IC3 is given as 2 milliampere. Then what they are asking, the bias voltage VB at the base emitter junction. चलो देखते हैं. They want answer for VB. What will be the value of VB for the circuit? So we are interested in analysis of this circuit. How we will analyze this circuit? देखिए जरा. So you can say the current here is 2 milliampere and Q1 and Q2 are identical transistors. So you can say this 1 milliampere current comes from here and 1 milliampere current comes from here. And the V into I product is equivalent to 1 kilowatt. So you can say this is also a 1 kilo ohm resistance. And this is approximately 1 kilo ohm resistance. Okay. So fine. And for AC, this potential is 0.7 volt. This potential is 0.7 volt. This is also 1 kilo ohm. और यहाँ करंट जा रहा है कितना 2, तो दिस इज प्लस माइनस 2 volt. So we can complete one loop in this circuit. We can complete one loop and loop will complete like this. We are interested in dB. So, okay. So this potential is minus 0.7. Fine. Okay. VB minus 0.7 minus 2 is equivalent to minus 12 volt. यहाँ एक लूप लगा दिया हमने ना. बेस इमिटर में हमेशा यू कैन अप्लाई द लूप व्हेन योर जंक्शन इज फॉरवर्ड बायस्ड, है ना. और फॉरवर्ड बायस जंक्शन चाहे वो किसी भी रीजन में हो, क्या फर्क पड़ता है. मींस यू कैन अप्लाई द बेस इमिटर लूप इन बेस इमिटर. You can apply loop in base emitter in two regions. First one is what? First reason, you can apply loop in base emitter region when your transistor is in saturation or in फॉरवर्ड एक्टिव. दोनों रीजन में लगा सकते हो क्योंकि दोनों की कंडीशन यही है कि एटलीस्ट बेस इमिटर जंक्शन मस्ट बी फॉरवर्ड बायस. सो यू कैन से द आंसर इज VB. The answer for VB is, the VB for the circuit is minus 12 plus 2 minus 0.7. Approximately 9.3 volt is correct answer. Approximately 9.3 volt is the correct answer for the circuit. So this is the idea how we can approach, how we can have the value of VB. Now what they are asking, the next question based on this is what is the mid-band voltage gain, and I leave this as a homework for you to find the mid-band voltage gain of this circuit. It's a you can apply the symmetry here, and this will be minus 1/2 GM into RC because it is single ended. We are taking output across one. इसके अक्रॉस आउटपुट पूछा है तो कितना होगा, और दोनों के अक्रॉस पूछा होता तो GM into RC. This is basic जो आपका एम्पलीफायर है. Now let's take one more example. What I can say, okay, let's take this circuit. Okay, this is the circuit. This is V out. VB is given as 0.7 वोल्ट. अगर 0.7 वोल्ट इसके बेस एमिटर में सेम पोटेंशियल होगा तो फिर करंट भी सेम फ्लो होगा. सो व्हाट आई कैन से, व्हाट एल्स इज गिवन, बीटा फॉर द ट्रांजिस्टर इज 100. दोनों ट्रांजिस्टर के लिए बीटा 100 है and VB equal to 0.7 है. So you can say if this voltage is 0.7, what they are asking? They are asking the value of V2. Okay, V out का वैल्यू निकालना है. V out का वैल्यू कितना होगा? What is the value of V out? So what I can say, if this is 0.7 volt, अगर इसका वैल्यू 0.7 वोल्ट है तो यहाँ करंट कितना होगा? You can say this current is what? IB. So this is 2 times of IB plus IC is 0.7. If this is 0, this is 0.7 और शॉर्ट सर्किट की वजह से ये 0.7. तो can I say 2 times of IC, 2 times of IB plus IC is equivalent to 12 minus 0.7 divided by 10K. So you can say 2 times of IB, 2 times of IC by beta plus IC is equivalent to 11.3 milliampere. Or you can say IC is equivalent to 2 divided by beta plus 1. So you can say it is 11.3 divided by 1 plus 2 by 100. And the value of IC comes out to be, it's 11.3 approximately. So you can say the 11.3 current will flow from here. It's not 11.3, it's a 1.13. Okay, that makes sense. It's a 1.13 है ना, divided by 10 है, 1 नहीं है. So what is V out? So you can say this voltage is 1.13. So V out can be written as 50 minus 20 into 1.13 volt. So we can say fifty minus 22.6 minus 50. So this is 50 minus 22.6, and which can be written as minus 27.4. Minus 27.4 is the value of V out. So they are interested in value of V out, and V out is given for the circuit is minus 27.4. So this is our analysis on MOSFET circuits. From tomorrow, we will start the concept of feedback amplifier. Feedback. And we will talk about the topologies of feedback. There are a lot of topologies in feedback: current shunt, current series, current shunt, current series, current sampling. So how feedback can help amplifier, and how it can increase the resistance or can change the resistance level, we will talk on tomorrow's lecture. So thank you very much.